to Mesa's session on IEEE 1815.2 testing and certification and DNP3 Users Group conformance testing. I'm Darcy Wheelis. I'm the Executive Director of the Mesa Standards Alliance. We're joined by Tyler Slay of Pacific Northwest National Labs and Ron Farquhar of the DNP Users Group. We're going to jump right in. We have a full agenda, so I'm going to hand it over to Tyler. Tyler, take it away.
All right, thank you. So we're going to go over our new and improved test tool for IEEE 1815.2. Quick outline. So we're going to go over the difference between our semantic and functional tests and how we're going to be creating our test report logs, which will kind of follow the CSIP standard for their reporting for their testing. We'll go over the front end, our test configuration, picks, and device under test, and then we'll cover kind of an outline of what the back end control station and outstation are doing. So if anyone is unfamiliar with your kind of traditional test setup, you'll have two devices. In our case, it'll be a control station and an outstation communicating. You'll have a test system that the test engineer will be coordinating your control station outstation with. And if you are running functional tests, you'll have an additional meter and some grid, either simulator or most likely a grid simulator. You can connect directly to the grid, but you kind of need a simulated effect to be able to take care of some of the frequency and voltage response tests. When you're testing, you'll have positive tests, which are things when you send a normal signal and you get what you're expecting. You'll have things where you want to send something bad to enforce that you're getting errors and getting the correct responses to stop bad things from happening. And then the functional tests are where your system kind of runs in an ongoing control loop, and you're going to be tracking the output. So for the current certification process, we have the semantic tests. What's required is its conversion of your spreadsheet into our JSON. Our tool does do that for you, but it starts with the supplemental material from the standard, that spreadsheet, and you can either modify that or do all the configuration in the tool itself. The requirement for passing the semantic tests is the 1547 mandatory points all have to interact as expected. If you're testing for 1815.2, you would also need to include those mandatory points. And then it's recommended that you go through the DNP3 protocol tests through the DNP3 user group, as well as cybersecurity certification. The functional tests do the same thing. You're required to get the semantic tests. But then we go through the UL 1741 SB certification, which is outlined in the IEEE 1547.1. And then for commissioning, same thing. You're required to pass your semantic and functional test, your semantic, and then your functional test is carried out in the field. And there's a lot of additional factors based off of the interconnection that you're working with, the interconnection entity that you're working with. So that's why commissioning is kind of its own ballpark. For the semantic tests, this is where your device, is it being configured based off of the thing you're uploading? So if you configure a spreadsheet and you upload it into the device, does it actually import all the points as expected? Is the device under test implementing all your analog and binary points, all the events, all of the bounds as expected? When the device under test is actually running, are you checking those bounds? Are you multiplexing your curves and schedules? 1850. I'm sorry, there's someone. Can you mute, please? Thank you. So in 1815.2, we have multiplex curves and schedules. So that's where you're having to allocate an external set of memory to move these points around. So need to verify that those are working correctly. And then are you enforcing that only points that you actually support are able to be written to and read from? So fairly straightforward. And then the functional side, Are you implementing your compatibility matrix, making sure that you're managing your priorities of controls and which ones are active? Are your curves actually switching between and following the specified percent var or percent volt watt, depending on what the curve type is? And are your schedules starting and stopping on time? And do they repeat on the schedule as expected? For the test log, the output, Sunspec has a conformance test procedure log format where the main JSON body is the tests carried out. So it's just an array of test names. The test context is for us would be the scenario that you're trying to accomplish for that specific um, test. And then the messages are, if you go to the next bullet, the message object where you have the timestamp that it came in. Was it a pass or a fail? And then did it have comments? And if it failed, you would expect it to have comments. The comments identifying what the UID was for what the point index was, what the value was, and then what the clause statement, whatever the issue was. So this is all for tracing through any of your failures and hopefully identify what you can improve on from your device to alleviate the situation. For the front end, we'll go through all these. These are all just tabs in our front end. The basic front end goes through a scenario-driven test procedures. So if you start, you configure your base picks and you identify which scenarios you want to run. And then it'll go into its test loop where it will run the first scenario. If there's another scenario, it will modify the picks for that specific scenario and then continue until you have no more scenarios selected, and then you'll have your report at the end. The various scenarios that we've outlined so far, and I think this covers basically everything for the semantic tests, is the configuration. This is that first load. Did you import your file correctly? The modify points is you take that base, you change some points, re-upload it, and verify the device under test goes through the control station, writes all those points, and the device under test, if it was the outstation, would actually update, and then you read back or get an event notification that that point was updated. Not supported is where you flip anything that wasn't outlined from the full 1815.2 specification of all the points. Anything that wasn't specified in your profile, you would try to write to that, and you would expect all of them to fail. Lower bounds, this is where you just try to write something lower than the expected lower bound, if possible. Sometimes you can't. If the lower bounds was at the limit of the integer value for transmission, you can't write lower than that. Upper bound, same thing. Max curves, this is where if you allocate 4 curves for your multiplexed memory, and that's specified in your profile, then if you try to add a 5th curve by setting the next curve index to 5, you should get a failure saying, nope, we don't go that far. Same for schedules. And then the functional and functional repeat. Functional goes through all of your schedules from start to stop. And once it's completed, that signifies that your function test is done. Functional repeat, make sure you repeat at least once for all of the schedules that have a repeat. These are still subject to change. We're still implementing the actual functional control logic. That'll be the last test and the last test procedure that gets updated. But these are the basics that cover kind of all of our original control objectives. For the PIC configuration, you have your entities, meters, DERs, inverters, batteries, the things of those nature. You have your binary inputs and outputs, your analog inputs and outputs, your curves, schedules, and then you're ready for the test runner. For the entity points, you can specify the number of meters, DERs, inverters, batteries, the historian points that are associated with each of those for your binary inputs, outputs, analog inputs, outputs automatically get added. So if you specify 3, you'll have 3 sets of those points automatically added to your profile. For binary points, This is where you can filter and select if you're going to be implementing it or not. Um, currently, we have dedicated profiles. So we have a mandatory, a mandatory for 1815.2, a mandatory for 1547, and then a minimal for 1547, which is kind of a special case. But in the future, we'll have full. You can just remove any point you want and add any point you want. But to start with, we're starting with the things that would be actually tested for, and then we can add additional functionality that lets you configure for a non-conformant system, just to make things an easier start for your testing. Analog, same thing. The main difference with the analog points is you'll have a value in your analog outputs that you can specify what the start of the actual like configured point value would be, or not outputs, but the inputs. That's where your system will specify your starting conditions. And then curves, this is where you can create your curve. We have a little diagram that kind of shows you what the curve outline is. You can specify what the type is, what the units are, and then individual values for all of your points. We do plan on adding some templates based off of standards. Based like 1547 has some standard points for your traditional curves, especially your frequency ride through and voltage ride through. We do plan on having those as just like template that you can just throw in directly. But right now it starts off as just like an empty curve for you to populate. And then schedules, we have the ability to add in your schedules, set when they start, stop, if what their priority are, all of that, set the power mode types, if it's coordinated charge, discharge, active, constant bars, any of those. And those give you a template for the points that would be allocated for your schedule. Currently, our scheduler is prioritizing the new schedule that has 4 points where you specify the time offset, action type, target point, and the value for that target point, which is different than the original backwards compatible schedules that only have 2 points, which is your time offset and your value to actuate. And those were basically turning on. You had to rely on a control to already exist, and you're basically just turning it off and on at a specific time offset, which doesn't really allow you to actually schedule a bunch of control modes for next week. And device under test configuration, this is where you specify what the IP address, the port, plus the DNP3 address. That's missing in this slide. So you'll have to, well, that'll be another additional property that you need to add. But we originally just set it to the default 1 for the control station and 1024 for the outstation. But we just went through an EPRI plug fest and realized that not everyone does the default. That was a mistake on our part. So those will be additional properties for configuration. And then the runner, this is where you will specify which device you're testing, hit the test runner, it'll go through all of your scenarios and spit out a test log at the end. So for the backend, all of the control station and outstation and front end is written in Rust. It's all going to be available open source on GitHub. We're currently trying to get that passed through our lawyers. We're getting very close, but there was, I guess, some type of conference or event. All of them were out last week, so I had a little bit of stagnation on that. It supports the PIX ingestion from the spreadsheet and then converts it to JSON. And then both of the backend outstations just load the JSON directly. The control station has a basic control flow where it just knows what the profile that it loaded is, and it tries to get the outstation to be that. So if it does an integrity poll and it sees points aren't matching what it thinks it's supposed to be, it writes it to it and tries to verify by getting either event signals saying the point was updated or if it doesn't get one of those, it does another poll on the event groups that have been specified. The outstations control flow tracks to make sure that the read and writes for the profile it has loaded are as expected. So they test against each other. This is something we saw in other tools where sometimes it would just be a one way. We wanted it to be, if you want to test a control station against your outstation, you can do that. Or if you want to test a outstation against your control station, you can do that either way. They're both just a reference design that check for expected behaviors against the other device. Control station checks, does the outstation only update supported points? Does it enforce its boundaries? And does it not mutex, multiplex? That is a mistake on my part. Does it multiplex the curves and schedules correctly? And then we were originally going to include the functional-ish, which is, does it enforce the compatibility matrix, enforce priorities, follow curves, and follow schedules into the tests? But it ended up basically meaning we'd have to do the entire functional control loops. And since that was the final priority, we've subtracted those out of the original semantic tests because they aren't really semantic tests. They are more functional tests. So those have been removed for the later date. And then for the outstation communication, does the control station only write to supported points? Does it write within bounds? Does it poll for supported points as expected, as if it was checking to make sure you were following your controls? Does it write curves correctly? And does it write schedules correctly? That involves setting the index of the schedule or the curve that you're trying to update, and then writing the points as expected to ensure that you go through the whole validation process. And that's it. So I think that gets us about perfect time. I said it'd take me about 20 minutes to go through the slides. So we should be able to.
Tyler, do you want to pause real quick before you go into your demo and just see if there are any questions?
Absolutely. That's a good opportunity for questions right now.
Okay, that was a good dramatic pause. Let's see. If there aren't any questions, then let's go right into the demo.
All right. So from past demos, always build before. Make sure it's running just in case. So this is when you download our GitHub, you just make dev or make prod, which is your production. That's our current setup. We do plan on adding a Microsoft installer and as well as just a cargo installer since it's all Rust based. But for now, we're just doing our Docker install and or a local install. So this goes through, builds all of your containers, makes it easy. It's one-stop shop. And then you just have to click on your front end's IP address, and it opens up your web page. So it starts off on our entities. This is where you specify, as I said, all of your entities. We have our meters, DERs, inverters. Default is it starts with 1. You can go less. You can do 1 or go to 0. You can add more curves, but ideally, if you're going to add curves, you just add another curve here. And then if you go back, your entities are updated automatically. So curves I wouldn't specify, but here is where you'd have to specify which number of meters you're implementing. So if I go to 2 and I go to like the binary inputs, I can see there are now multiple meter sets. And then I can go back to entities and make a third. And we have our third set of meters. Same with the historians. They just continue to append the additional number based off of whatever this count is. When you're configuring, right now I have the current profile. I mentioned we had 4 profiles. You can specify, we have our mandatory 1547, minimal 1547. This is a special case where it removes all of your historians. It removes all of your curves, because there is a statement in the standard that says you can load those, preload those and just have them as something you could read in, but it doesn't need to be something that's pre-configured in your profile, so that it just removes all your curves and also removes all scheduling. So it's like the bare minimum number of points you'd have to start with. And then mandatory 1815, that's where we remove all of the optional controls from the profile. Uh, and when you're configuring, if we go into something would be a little more uh, informative, you can specify based off of the type of control you're looking at. So if we wanted to configure our const var, you can filter for const var. You can set this, set your values to whatever you're trying to get to. Um, you know, specify various points. Um, this is just a convenience. You don't have to filter. You can just go through. But if you notice, there's a lot of points specified, and this can take quite a long time if you're trying to figure out a specific function. So that's why we added this filtering feature. Jump into your batteries, nothing in batteries, other than the pre-allocated vendor points. Oh, that's a bug. This shouldn't be called vendor points. Just notice that. Uh, See, you find something new every single day. Anyways, so moving on. So that's basically what you go through. You can uh, see all of your points that you have currently in your profile based off of what you've loaded. And in the main place you would modify points is inside your analog inputs where you'd specify values. I am going to make a comment in our next par to add in a value for our binary inputs as well. So you can specify starting binary. So you can say which things you want to have like enabled versus which do you want your controls to start off or start on? Do you want your errors to start on just as like a flash to make sure your system is showing all your errors at first? This would be, I think, where you would implement that rather than how the standard currently says to kind of just default on whatever your outstation wants, and you're just reliant on polling from the control station to see what the outstation did. So for curves, this is where I was saying you can specify, let's go an HVRT, high voltage ride through, must trip. We can specify this is just very demo oriented. Go 4, -1. That looks like a curve. Not great values, but this gives you a good idea of kind of the visualization of your curves. And then you would want to make sure that you are setting your axes correctly and time. I think I set that backwards. Time and the ref, so we can make sure that things are aligned as expected. And then the scheduling, we can show this bar is in the way. Get out of here. There we go. So we have a couple schedules right now. This shows the resolved schedules based off of the current priorities. So if I switch this to priority 1, whichever one was the last sent is considered higher. But if I go to 3 and then switch back here and go up, now I can kind of toggle between the two, which one's active. We have a little calendar selection for when you're creating schedules. You can set the different times. There we go. So now we have kind of the stacking. So this just makes it easier for you to go through your schedules and select your modes and add various points. And then we get into the test runner. This is where you will specify what scenarios. These are all of the scenarios you can run through. We talked about the configuration. This is where you're just checking to see if the outstation loaded your points correctly. This is where we go and change all those values by some amount of points. Unsupported, this is where we check to see, did you implement the points for that specific test? If you didn't, then we will send points to it to see that you are not accepting those lower bounds, upper bounds, max curve schedules. So if we go through here, and I did this this looks bad, but I wanted something to show that it wasn't just like, hey, we're perfect. So I just changed on the tests themselves. I changed a couple points to force a couple failures so we'd have something to look at other than just pass. So we have just checking and it's saying like, hey, we tried to schedule this and it didn't update that value. Unsupported. These are all supposed to fail. This is what you would have seen for everything else was all of the things were green, which would have been really boring. Same for our curves, upper bounds, and max curve schedules. The last thing that we are adding is the test report. Currently, this just downloads your entire log of all of the points that were written to and received from the outstation. But our actual report log, as we described, is going to be the JSON, the SunSpec JSON format. But that was the last thing on our to-do list, and we didn't implement it before this demo. Unfortunately, we got tied up with the EPRI demo and end up not implementing that yet. But that's the next thing that's getting pushed, and then that'll be available once the GitHub gets pushed in the coming weeks. So now, are there questions, or is it that good?
Feel free to chime in now, or you can put your questions in the chat.
Well, let me ask a question, Tyler. Is there a way of setting, say, upper and lower bounds in a more global way than one-on-one?
No, there's not. And I don't think there's any way, like, I don't think it makes sense because most points have very specific bound specifications.
Well, I was thinking, for instance, of the historical or equipment ones where, you have DER units and inverters and so forth, and you might have 20 of them. So that was my thought, not necessarily per function. But
So when you're,
that's the bells and whistles rather than the basic requirements.
yeah. And so currently, our setup doesn't allow the modifications of the bounds. It was starting with what was specified in the sheet. But we are going to add in the reference to the bounds. But if you think it'd be helpful, I don't know. So if we go to like one of our purposes, like active power, I don't see how you would be able to not individually set bounds because you're looking at time windows, ramp times, time period. Those are going to have dramatically different bounds just in those 3 points.
Well, but all time windows may be the same, and all ramp times may be the same. That's the kind of thing I'm thinking about.
I think it's still too hard to make a generic one. I think it's easier to start with the spreadsheet itself having a more generic, like right now it's very open. I think it's better to start with like a generic time window for all in the spreadsheet and then
Okay.
allow the user there to manipulate.
Okay,
Because yeah, that
so
would
do
be
it in the spreadsheet.
that would
Do
be
it
a
in the
lot of
spreadsheet
like
ahead of time.
fine-tune things to add into the front end for configuration.
Yeah.
Yeah.
We
Okay,
do
so
have Francis, I'm going to table that for now. We have a question in the chat. There's a vision asking if there's a vision for how utility may use this tool to assist with commissioning new DERs, or is this primarily intended as a testing product for 1815.2 compliance?
It's primarily as a testing product, but I think utilities would benefit just from the user interface of creating the picks. I don't know if they're familiar with the current spreadsheet, but it can be a little daunting when you first open up. There's a lot of points. And this gives you just a little bit easier access to manipulate some of the points. But uh, yeah, it's primarily for testing and for developers who are trying to understand if their system is running as they would expect.
Great, thanks for the question, Brian. Other questions? Okay, I'm going to hand it over. Feel free to chime in with a question. Well, Ron, why don't you go ahead and start your screen share? We're going to switch over to Ron from the DNP3 Users Group, and so they can talk about their conformance testing. The Users Group and MESA strongly recommend that folks go through this initial step of conformance testing with the Users Group before they go into 1815.2. It will make it a lot easier in the long run. So Ron's going to give you the specifics. And yes, Ron, we see your green glowing tent. It's beautiful.
Perfect. Yes, good. How's
And
that?
there are your slides. Perfect.
And no, I'm not in a green glowing tent, right? I might feel like I am, but I'm not actually in a green glowing tent right now. Thank you, Darcy. Thank you for the opportunity to just give a brief update and explanation of the users group and what we are doing or what we have been doing with the Conformance Certification Program. This is something we've had underway and in place for quite a long time. And but just to take a quick step back and talk about the users group, I'm not sure if everybody on this call on this meeting is familiar. But before I do that, I went over my own bio that's available for looking at in the future. But we also have a small team here from the users group representing different aspects of what we do. We have Sarah Ewell, who is our membership coordinator, and you'll see her email address in the deck. We also have Derek Ewell, who is our Conformance Certification Program coordinator. So specifically to what we're talking about today, Derek coordinates that activity. He's a point of contact for that. We also have Andrew West, who is the chair of our technical committee and is a significant resource technically, obviously, and Doug Keene, who's the secretary of the technical committee. So thank you, everybody, for attending today and supporting this effort. So just briefly, what are we doing and why do we do it? So the ultimate or the fundamental reason to have a users group, whether it's MESA or to have the DNP users group, is cost and risk reduction by supporting interoperability and tools and the kind of things you're hearing about from Tyler and so on. That's why we exist. That's what we're here for, is to develop these standards and support interoperability. Our services include a wide range of things. We do free industry workshops and training, and we have technical support for our members and quite a significant range of things we can offer. And then, of course, we're developing standards all the time and test procedures, which is a huge investment to develop these at the protocol level for sure, and then guides and so on. We also then, in terms of the standards, we were involved with MESA. It was a kind of a joint throughway effort, obviously with MESA, the IEEE, and the users group had people participating as well. We are in the process of updating the main standard itself, significant updates. We're also developing, in all of our spare time, 2 new cybersecurity standards, the Secure Session Layer DNP3 SL and AMP Authorization Management Protocol. And so these are 2 major efforts. We are receiving a little bit of DOE funding, we think, soon to support that. But you can see how we could get to 4,100 hours and about the same in 25 as well of volunteer time when we're doing all of this work. So that's kind of a very brief snapshot of the things we do. Our mission statement includes 3 or 4 key areas, interoperability being the #1 priority of what we do. And so all these things I've highlighted in yellow, they actually speak to, or they're major aspects of how we do foster and improve interoperability. We want to optimize that, reduce utility risk, reduce vendor risk. And so conformance certification is a big piece of that. We have other elements that are very important for that as well. Membership fees, just FYI, are tailored to the size of the company, whether it's vendors or utilities. And so just very briefly, and reach out to Sarah if you'd like to, if you're interested in more information on membership. So our program, as Darcy has mentioned, we strongly recommend the DNP Users Group Conformance Certification Program first. It's important to understand that what Tyler has gone through, what MESA is doing, which is super important, is testing the profile. This is the mapping. This is at a level, a profile level that's running on top of, if you want to simplify it, on top of the protocol. It is not the protocol itself. So a thorough risk-reduced implementation for vendors and utilities has a certificate of compliance, of conformance from the users group, followed by their certificate, the test certificate, the test tool use, and then the UL certificate that is established between MESA and UL. It requires both. Otherwise, there are risks involved in the protocol itself. And so that's what this slide is talking about, is that it's a two-step process, is what we are strongly recommended. There's no legal mandate here. It's just all about being wise and smart in what you're doing with all of this. And then in terms of the business case, why look at this? And it's a similar business case really for both steps, both the MESA test and certification, and for the users group. We want to enable and support maximum confidence in the product, in the system, in the implementation, in the deployment, utilities and others that are deploying this equipment. Certainly, the more tested, more thoroughly tested a product is, we can say that it speaks to the quality of that product. And then by definition, it can give a competitive advantage to the vendors and suppliers that have done this versus those that have not, and an extension to credibility as well. In some places, at some cases, regulatory compliance is a factor, but certainly risk reduction. Absolutely. And we used to have this adage back in the day that costs to correct issues and problems. And I was with GE for 25 years. And so I'm familiar with addressing all three different approaches to correcting problems. You can have after shipment, before installation, which is roughly 10 times, you're sending people to the field, but maybe not dispersed to the field, might be to a utility staging location. But the maximum worst case is to do corrections in the field. And we all want to avoid that. However, whatever it takes, we want to avoid that. I've lived it. I know what that pain looks like. Here is a summary. This is not the full list, a summary of the list developed by our technical committee. When we asked them, could you develop a list of the things you have seen in your consulting business, or if you're with a vendor or you're with a utility, where the problem was detected related to the driver, related to the DNP driver, and it was an issue that would have been detected through our conformance certification program. And so I've highlighted just some of these in green, but there's some very significant things. This is not old stuff. This is relatively recent issues that have been identified or found during testing, and that would have been discovered in advance if that implementation had been conformance certified. Little things, quote unquote, little, like the operators, look at number 8. Operators could be shown incorrect data on the screen, which could lead to wrong actions. This is real world stuff. And this is at the protocol level. These kind of things won't show up at the tool level that Tyler is talking about. So what is our program? Basically, it requires the use of our latest test procedures, in this case, version 3.1, which was published in November of 2022. It addresses subset level 1, 2, 3, if you're familiar with DNP. These are large and detailed documents. The test tools that are developed for the protocol, such as triangles and ASEs, I want to say there's more than one vendor, are based on these test procedures. Our members have access to the test procedures. They also have access to our device profile guide, which is another detailed document, so they understand how to configure the device profile. And then also members have support as part of their membership if they have questions and need guidance on all this. Finally, the reviewers that do our conformance certification reviews, they work according to a CTR conformance test review guide that we have developed. So there's a lot of documents, a lot of things that we have developed. So here's just a pictorial graphic of the test procedures on the left, just to give you an idea of the scope of work, the extent of work that the users group has done to support the certification program. The program consists of two primary phases. Phase one is the review of our profile, of the device profile. And this is where the detailed configuration is defined. And that is the first major step in achieving interoperability. The second phase is where the vendor or the utility, or the vendor on behalf of the utility, whatever, would submit the conformance test results in the form of test logs from the test tool. So again, in a similar way to what Tyler's talking about, you have logs that are produced by these test tools. We review those test logs, and we have found this to be a time and cost efficient way of doing this. And a lot of the results gives us a pretty high level of confidence. We always find things, no matter who it is. We always find things when we go through this. Our people are very good and have a lot of experience, and they can pick up issues quite quickly. Upon successful completion, then we provide a certificate that looks like this, and there's a date. It is signed by the manager, the chair of our test management committee, and now that product and that particular version of software in detail. You can see the detail that is provided, that is required to specify exactly what that product was, is all stated on the certificate. So this is a summary of the two-phase program, where the vendor initially would reach out to Derek, our CCP coordinator, where there would be an interaction. There is some funding involved. It's not major, but there is some funding. Phase one first, then feedback on phase one, then the phase two, the conformance logs, feedback on that. Once successful, then the certificate is issued. I just wanted to say, just to clarify, our phase one and phase two is separate from the MESA phase one, phase two, which you would have heard about on other workshops. And so basically, the next thing then would be the cybersecurity. So we have existing a version 5, SA v5. That would be what we would call phase 3 of this. It would follow the phase 1 and phase 2 that we've talked about, and that becomes phase 3. And then another certificate would be issued, or a combined certificate, if it's all at the same time, would be issued for the full conformance certification effort. So now we're adding the optional phase 3. Just a note on this, there is another generation, which I referred to, the DNP3 SL and Authorization Management Protocol. Those are under development right now. DNP3 SL is pretty much done. It is included as a draft with the IEEE that's being balloted, and the first ballot is complete. We are now doing comment resolution. So that is close, and then AMP is under development. Those will compose part of phase 3. They'll become the phase 3 test in the future once they are published. But you can see the importance of what the users group is doing, because we are now going to add cybersecurity provisions onto the protocol, the next generation of cybersecurity onto the protocol. So our primary contacts, I should say, as I've mentioned, Derek's on the call right now, on the meeting right now, our Conformance Certification Program Coordinator. Michael Dude is our VP of Services. He is a primary contact, probably our initial primary point of contact for technical support and questions on implementations and deployments, that kind of thing. Sarah is our membership coordinator. And so these are the people that are available. And so this slide will be in the recording on the deck for future reference. If you can take a picture of it right now, if you want to reach out to us. And yeah, I'm a little quicker than I was planning to be. But any questions for what I've gone through? Let me ask a question back to the group. Are there things that I've talked about that you may or may not have known? Is this new information, or things that you largely knew about? Are we always looking for that kind of feedback? Anybody want to speak to that? Okay, well, thank you very much for your time. I appreciate your listening, and I'll turn the mic and display back to Darcy.
Thanks so much, Ron. Yeah, we have a quiet group today. Feel free to
Yeah.
chime in. We actually took this out of webinar mode on purpose because we wanted to make it a little more interactive because we figured we would have a smaller group. Okay, I just wanted to circle back to, if you're not familiar with Mesa, let me get this in slideshow mode. There we go. And then can you see, how's that, Tyler? Do I have it set up the right way? All right.
Looks good. Yep.
So at Mesa, we're a cousin of the users group. We're another industry association. We're back it went. We have utilities and vendors who are really working on interoperability for utility scale DERs. And that could be solar, storage, wind, microgrids. And we really want to make sure that these devices can be interconnected easily. And we do that by, as you've seen, creating these standards that are now, that is in the work, Mesa's primary work has now been incorporated into 1815.2. And as Ron said, it was a joint effort with the users group, built upon users group great work. And we partnered with IEEE to get this new standard out the door. So we want to, now that we have that standard in place, we want to make sure that we can have a testing and certification program to make sure that it can be implemented seamlessly. Let's see, so just wanted to give you guys that little bit of background. And also, join Mesa, join the users group, join both of us. We're here to help you. We're here to make this go easier. You can access the 1815.2. Both Mesa and the users group members have access to that because we all have joint IP. We also provide technical assistance if you want to know if you need help implementing 1815.2. If you have questions, you get technical assistance with your membership. We have work groups so folks can share lessons learned. We have work groups on how to update the standard and make it better. And we have just general meetings. If you have an interest, we're happy to work with you and get you what you need. But you'll be working with the people who are actually creating the standards. You heard Francis earlier, Tyler, Ron, several of the other folks on the users group side. We've all come together to make this happen, and we're here to help. Quick hit on what it costs. We try to make it relatively affordable, a maximum of $5,000 per member, a little bit less if you're a smaller organization. And then we rely on discretionary technical allocations. This is mostly utility members, but some of our vendors also provide us extra funds so we can help keep those membership fees low. Again, I wanted to end on this slide. I grabbed some of the users group contacts as well, just so you guys can take a screenshot of it. Again, these slides will come out, so you'll have them. And just want to go ahead and see if there are any other questions that folks may have about this testing and certification program. We are recommending both steps. Start with the users group and then come and get your 1815.2 certification. If you are going to get your 1815.2 certification, you'll be needing to go to UL. We are working with them. Oh, and I should mention that Mesa members also have access to an implementation guide for 1815.2. It's another membership benefit. And we will, right now, we have a PNNL has the tool. There may be other tools or, if you're wondering which tool you should use, please, again, come ask us. We're here to help. So I am in presentation modes. I'm going to get out of the screen share so I can actually see folks. Any questions for today?
I guess I do have one question, which ties back to this previous question of a utility using the test tool.
Mhm.
Is there anything that stops a utility from using this tool to make it easier to test a new DER site? I guess because
No, it'll be open. It's open source.
okay.
The PNNL's tool. So we need to get some of the bugs out. We want to test it with, run a few Mesa members. I mean, what you're seeing is hot off the press.
Mhm.
Tyler and his team have been working on this for several months, and we are going to get a few more kinks out, and then put it out there. And then, again, as soon as we get free feedback, we'll be improving it as we go. As Tyler mentioned in the notes, they're open to new features. This should be a continuous improvement process. And if there is something that we can do to make it easier for utilities to use, we're happy. And they're planning. We're happy to accommodate.
Okay. Do you guys have any other sort of recommendations for how a utility could test one of these sites and sort of limit the burden on the utility?
What are you testing for specifically? And Tyler, I'll let you answer this, I think.
Well, I guess it would be 1815.2,
Okay.
testing all the analog points, all the binary inputs and outputs.
Okay.
To make sure that the DER site has implemented their side correctly.
I think if that's what you're trying to accomplish, this tool is the perfect thing to start it up and just see if things are looking as you expect. There's always going to be additional, like if you have some back-end business logic that creates new schedules for next week's voltage curves or like wind profiles, whatever, that's where you're going to have your own internal investigation on how you're going to integrate that. But if you're just saying, like, I have a new client that wants to connect, this will be an easy way to let me just check and see if everything matches, and then you can move forward from there.
Okay, perfect.
Another thing you could do, and we've been talking, we presented to EPRI a whole bunch of different utilities earlier this year right before or right after, I can't remember, 1815.2 was published in February. We're really strongly encouraging utilities to require 1815.2 certification, and then by default, since we are recommending the users group certification, if utilities could require ideally both in their RFPs and their technical documents, that is really helpful, because then you have that utilities have that extra, confidence that the products that they're bringing in have been tested, and vendors have the confidence that the products that they're creating are working as expected.
And if I can just add to that, Darcy, with the users group, we included it in the membership fees, depending on the level of membership. We include discounts for our conformance certification program. So a utility could take their membership discount and provide that discount to a vendor of their choice. So you have a primary DER device vendor, you could see a significant discount allocated to your vendor to walk through that program, and then they would have a certification. At that point, it's a win for them. It's also a win for the utility, and then go into the Mesa test certification after that. So we're doing all we can to facilitate and encourage what Darcy is saying, is kind of that two-step process. And it would be ideal, as Darcy said, if utilities would require this. It would certainly reduce their risk and reduce the risk that the vendors have. It's just a discipline that we haven't really become good at in North America. In Europe, they are much wiser with this. We're not that good at it. But there is pain out there because of that. If you were to ask for a very frank opinion of vendors that provide, for example, ADMS systems and so on, where some of their pain points are, they have to expend a disproportionate amount of money customizing things and testing things because we have not been disciplined as an industry, and that just puts a drag on the development budget that they have to carry. Rather than putting all their money into new features, they have to continue to revise and update their drivers and so on, which also in itself adds risk. So yeah, I could go on for an hour about that. I'll stop now.
Yeah, and just we've heard it can take days to weeks at final commissioning to get this without it, if you're not using 1815.2, if folks are just coming in to do custom integrations. So it only delays you a day or two, but we've also heard stories where it's taken weeks to get the DER to talk to the utility SCADA system. So
yeah,
that's what we're trying to avoid.
It definitely takes hours, if not days, weeks, maybe.
Yeah.
But
weeks is the worst case scenario, but it happens.
Are you saying that this DER site would go to you guys to get certified?
Yes.
And that would reduce the burden on the utility.
Yes. Mm-hmm.
And we potentially could require them to get that certification.
Absolutely.
And now that it's
reduce our burden. Okay.
Yeah, and now that it's an IEEE standard, it's a lot easier. It's not just an industry standard, it's an international standard. So add it to the list of things that you require, please.
Okay.
Yeah.
Thank you.
And if you need help, Michael, with wording on that, we can provide you with a little bit of simple guidance on just the words to put in, the hooks to put in the RFP document, so that it helps with the vendor to be clear on what you're asking for.
Okay. Yeah. Thank you.
Other questions? We have a couple minutes left. All right, hearing none, I want to thank everyone for joining us and appreciate everyone's participation today. This recording will be posted, and we'll also send the slides around.